Yes,
Yep.
you just need to maximize the view.
Yep. And uh, okay. And yes, I've been thinking about what to present in there, and the last couple of weeks I've been in places somewhat remote, including one island which total population is 600 in the middle of the Indian Ocean. So some challenges um, in talking to people and also developing something to talk about. But in that context, I figured that there are a range of diverse issues which come across when reviewing all the observations that come through, that it's be useful to highlight. Um, and I want to put this in a context of things to think about, issues of potential concern, but not necessarily of criticisms of uh, people, but issues which need to be thought about. Now, hopefully this works. We've had a couple of presentations today talking about GPS flashes and the Astrid system, which looks to be really fantastic. But underlying everything we do, the single most critical component is having accurate time. Doesn't matter what else, how fantastic everything else is in your system. If the time is not reliable, the results get compromised. And you need to have total confidence that your time is reliable. And this year, we've had 3 notable instances where time has become, or reliability of time has been of concern. The first one was an asteroidal moon discovery where there were 3 chords. One involved the use of flash timing, and there were concerns about the reliability of the timescale for that flash timing, and that prevented further information about the binary system being able to be established. More significantly, perhaps, was Didymus. We've had 3 occultation successful, 3.5 successful observations of Didymus this year. The first one was by Mike Skrotsky, who happened to be in Melbourne, Australia, on a work thing at the time. He was successful in getting a chord for Didymus. We reduced the results, and then the people at NASA, JPL, they came back and said, "Oh, this, are you sure about this? It's requires a serious displacement for what we expect." And Mike's processing of his time, we didn't fully understand, and the issue arose of whether there was a time-based error, and that caused great concern. I should say that after months of investigations, we concluded there wasn't one. Subsequently, there was John Broughton's observations of Didymus, which got a very nice fit and looked all very good. But then the latest observation of Didymus indicated that perhaps John Broughton's observations had problems. And underlying all that, the Broughton observations was question about time-based errors surfaced in there somewhere. Explanations, we haven't found a time-based problem there. But in all of this, the challenge we have is when we have an unusual result, we need to have 100% confidence in the way we have determined time. If we don't have confidence in that in a fairly immediate upfront way, then when you've got a difference between what you record and what you're expecting, the issue of time base can surface. Now, Kevin was talking about the excitement and so forth of occultation observations. The Didymus event is a really good example of what can get achieved, because firstly, Mike Skrutsky's observation turned out to be fully consistent, and the problem there ultimately turned out to be that the people at JPL, in their driving the orbits, hadn't included a particular effect associated with the impact. And subsequently, when they included that, they could fit the observation. But then the problem was with John Broughton's observation, to get that to fit, the effect involved was much larger than they expected. And the final observation gets a fit which overall fits the expected but previously unaccounted for effect of the observations. All of this, in terms of significance, has relevance to the targeting of the HERA probe that's due to be launched in a couple of months. And we're working at a level of precision that can't be achieved by other techniques, by our simple systems. So time is really, really critical. I can't overemphasize it. When we get involved with really, really important observations, it is really critical. One of the issues that have concern to me is, as we've gone from video to the CCD type cameras, how we ensure time reliability in that, potential issues of people doing do-it-yourself solutions to it. There's underlying all this is how have you tested for accuracy and reliability? I had a friend years ago who was heavily involved in precise time stuff, regularly going to Geneva for international meetings on precise time. And an issue that he regularly drummed into me was with precise, when you're after precise time, the question is, how do you know? Have you covered everything? And what assumptions are being made when you put things together? You've got to make sure that you encompass everything which can occur between when the photon enters the overall system, gets past the first optical component, to when a timestamp is applied. In the past, the video context, we had Gerhard Dangel and others did a lot of work on video and has fully documented the types of issues involved with time stamping on video, a well-documented environment. It seems to me that we don't have that with the CCD type cameras. That's of concern to me. Also, when I listen to these talks, and I don't have detailed knowledge about how cameras work, at the level of detail required. But one of the questions in my mind is, when we develop things, time solutions with CCD cameras, are we sure that there are no time issues associated with how the camera is used, full frame versus subframes? Are there actually any time delays between when the exposure actually occurs and when the signal comes out of the camera? What assumptions do people make about that? Have people done testing to ensure that there are no delays within the camera? And is there any issue about potential delays being dependent upon the camera? Issues that I don't profess to have any specific knowledge of, but when coming to the question of ensuring you have really precise time, you need to consider all components and the possibility of delays in any component which you have not tested. So I think the final point on this, I think, I think IOTA should have some form of process of either recognising a time system as reliable, such as what Steve Preston and Michael Camilleri have been talking about, but more generally having good documentation about which systems we are fully confident of as being reliable. Because otherwise, when something goes wrong, or you get a really interesting result, as we had with Didymus, if you don't have 100% confidence in your time, then the discussions, analysis stuff get compromised between what was expected and is the occultation result reliable. One of the things which drives my concerns on time is the process of reviewing all observations that come through. It's not uncommon to see issues like this one. The plot at the left there shows the overall event, and I've highlighted 3 chords at both ends, which I've expanded. And when you look at those times and look at the location of the uncertainty bars, chords 3 and 4, very much the same length, but displaced in time. Is that a time-based error? Or some people say, oh, is it just a feature on the asteroid? Of course, in this situation, if you're going to explain a mountain on the left-hand side to cause the location of chord 4, and then a corresponding valley on the opposite side of the asteroid, that is highly unlikely to have that type of correlation. The questions with these 3 chords in my mind is there a problem with the time base of at least one of those chords? And are the uncertainties associated with those times appropriate? Chord 4 has very small uncertainties, but the times are inconsistent with both chords 3 and 5. Is there a clear answer to that? Well, no, but starting position is, are questions about the reliability of the times associated with those chords, with very difficult to figure out which one is correct. subframe timing. This is an issue where some people are very keen or focused on having the greatest time precision at all possible, and are keen to report at subframe or sub-exposure intervals. And I've seen reports where the uncertainty is given as small as 1/10 of the exposure interval. So you might have, say, exposures 0.1 seconds apart, and they'll give an event time of plus or minus 1/10 of the exposure. Well, given the noise that we typically get in our signals, I think that accuracy is probably unjustified. But more significantly, when it comes to pulling observations together, when we're dealing with asserted time accuracies of less than five milliseconds or so, that asserted accuracy is in practical terms pretty much meaningless. For a single chord event, if you're doing a single chord event, you have the problems of it being just a single chord event, and the uncertainties associated with single chord events in their cross path direction is plus or minus 40% of the asteroid's diameter. And if you're dealing with multiple chords, then you've got the asteroid shape models to deal with, and the irregularity and the spacing of the chords. It's fair to say I can't recall of any instance where time accuracies of better than 10 milliseconds has had a significant relevance to the reliability of the overall event. My basic reaction is I have no problems with asserted accuracies less than of half an exposure or a bit less. But when it gets to a small fraction of the frame or exposure, I fear that there's all sorts of issues in there which haven't properly been worked through. And on the IOTA group, I recently saw a comment that I think the comment was saying, hey, I doubled the exposure, but I could still maintain the same time precision. It was an interesting comment, because if you followed that logic, you take a series of 1 second exposures, and then you haven't lost any time precision, so I'll still have a 30 millisecond time precision. Basically, the level of accuracy you'll have with an exposure, with a series of exposures, is inherently tied in with the exposure length, and doubling exposures and so forth, you necessarily lose some time resolution. Another issue, subtiming assumes the star is not a close double star. And if you're not careful, the time and the time uncertainties become erroneous in that case. And the final thing which people will not appreciate is that in the astrometry that we derive, we get a certain levels of uncertainties. But when the observations are incorporated into horizons in their orbit solutions, the uncertainties or that they actually apply is larger than what we report. So main point here, don't focus on trying to get the best time possible, the smallest uncertainty possible, because it's almost certainly illusory. I think the first first comment I've largely covered, single record events on small asteroids are highly valuable. Indeed, for a very small asteroid, once you get down to asteroids certainly below 5 kilometres and generally below 10 kilometres, you're getting very good accuracy. But you must keep in mind, for a single record event, their cross-path uncertainty is set as plus or minus 40% of the diameter. So the smaller the asteroid, the better, and the larger the asteroid, the worse. For a main belt asteroid, if the asteroid's above 100 kilometres, maybe even less, a single record observation is not of great value. Forget the next line there. I put this together last night before I came to bed. Yes, forget those next two lines there. Small mag drop events. They are clearly an attractive challenge to observe, and I've found that myself. When the light curves have been coming through, which have been damn good to have, and I'll talk a bit about that, I've seen enough of those light curves to note that for events that recorded, the interpretation of quite a few of these events is questionable. People's desire to be able to record a really low magnitude drop event overrides the other considerations in what you're trying to get from an event. I think the real challenge for observers is to distinguish between the situation where you can claim, I saw an occultation with a magnitude drop of just 0.1 mags, as against those situations where it's very clear you got an event and I can reliably determine the event times with a good level of precision. And from what I'm seeing with the light curves coming through, this is a real issue of being able to claim I've observed versus I have an observation which I can derive something from. Because of the issues with these events, I'm seriously considering the situation that for events with a mag drop of 0.4, if no light curve is provided, and provided such it can be included in a Visier set of light curves where anyone accessing the observation can retrieve it, will not observe that observation will not be processed. It's just too open to being unreliably interpreted. Prediction uncertainties. With the FDR3 release of data, Horizons has included now the FDR astrometry of asteroids, huge number of asteroids. And this has had a potentially profound impact on how we should be going about observing events. Because the FDR3 data has drastically reduced the uncertainties for asteroids which they have a suitable number of observations for. The first These bars I have on this plot are from a Cult Watcher. The colour scheme I've used is mine. On the top one, you can see the green bar is the predicted path width. And then you can look at the uncertainty bars at either side. Those uncertainty bars are very, very small compared to the diameter of the asteroid. What's the value of a single chord observation for that asteroid? Very, very little. For that type of asteroid, the focus, we need to have a focus on having multi-chord observations to focus more on determining size and shape of the asteroid and position of the asteroid is not a primary consideration. On the other hand, the bottom chord is a more typical one, particularly for small asteroids. When you see an event in a Cult Watcher which has uncertainty bars like that in comparison to the expected path width, those events are very valuable for single chord observations for astrometry. And of course, if it's a small asteroid, then unless you have a dedicated effort of putting telescopes across the path, multiple chord observations are very unlikely. Point here, focus, have a look in a Cult Watcher or a Cult Watcher cloud at those uncertainty bars to identify the value and the focus of the effort that should be made to observe them. Now, light curves. Getting light curves now for the great majority of positive chord observations. And in a Cult, they're displayed with the event. I'll give a very quick demo of that shortly. These light curves are having a major impact on reviewing observations and overall confidence in the results. Some light curves are extremely clear and event processing proceeds quite quickly. Other light curves lead to a reaction of reaction of, are you sure there's an event there? Sometimes the basic reaction is more like, you got to be kidding. In the overall processing at various stages along the processing, we've picked up several instances of double stars and got one instance of an asteroidal satellite, which from Norm Carson, which we still have to process, but it seems fairly certain, which the observers hadn't identified. One of the peripheral values of these light curves coming through on a routine basis is various skilled people with skills of interpreting light curves will pick up things which the observers haven't recognised for whatever reason. I wouldn't expect an inexperienced observer to pick up detail in light curves, where an experienced observer will pick it up. And that's an important byproduct of submitting light curves. I also have a strong view that for the reliability, for the to maintain the credibility in our observations, the ready availability of light curves is important, so that anyone querying the observation can readily access the data that the observation is on. Now, I've recently become involved in a project that's combining occultation astrometry with the Gaia FDR3 asteroid astrometry. an initial part of that process, they were fitting orbits to the FDR3 asteroid astrometry, and then checking our astrometry against the orbit they had derived. And they came up with a number of events, many tens rather than hundreds, where the question was asked, are you sure about this observation? Because it doesn't match the Gaia data. And for the recent ones, I'd say, well, here's the light curves. There's no doubt about it. And then the focus got moved to looking at the Gaia data and whether it was adequate or whether the data from Gaia was sufficient to enable a reliable orbit determination. Can't overstress the value of having light curve data readily available. In this regard, if people have in your cold weather, or people with lots of spare time, if you've got the time and you've got the past files, consider going back through your old observations, light curves, and create light curve files for them. You might, in fact, find some interesting things there. Now, hopefully I will, how am I going to do this? Thought I'd try to do a quick demo of what occult does with light curves. Hopefully this will all work well and illustrate something comes up here. There was something that came up on the groups the other week about they thought there was, hang on, I've lost something here. I need to shrink this a bit somehow. Oh dear. Just bear with me for a second.
If you can discontinue your PowerPoint, then you'll see your computer monitor screen a little better.
Yeah, now, yeah. Okay. Discontinue that. Okay. So, all right. There was a comment or question the other day on the groups about, I observed this event a year or two ago, and I looked at OWC and with past events, and it wasn't listed. Where is it? What's happened to it? Well, there's some aspects in our processing which depends on when things get updated. The critical thing is occult provides a definitive source of data. Now here is, let me chop that down out of the way. Here's the occult main form. That's the prediction things which lots of people are used to. Here's observations. There's a whole heap of stuff under there. If you wanted to find all your, I'll just show this. If you want to, I'll put my name in there. I can list all events that I've observed. It also gives a list of all the sites I've observed from. There's a whole heap of info down there, which people might find interesting to play around with. The critical thing, though, is I won't go into light curve viewer because that's also relevant, but asteroid observations takes a little bit to load some of this up. Here's a report form, the editor form. For those that haven't used it, which is probably a large number of people, forget about most of this stuff. For viewing an event, you need to look at this box here. You can select here a range of dates. I'll go down here for argument 2011, and here's an event. 2011, January 8th, occultation by Medea. 25 here, you can see this 25 observers and 23 positive chords. And there's a plot of the event, and there's a shape model fit to all the chords. Comes up that quickly. Now I'll pick up a more recent one. Here's my note, 224. And a long list here, 430, 21564. This one here. This one doesn't have a shape model. This is a 3-chord event. You see there. If you're looking at this, there's a heap of options here for displaying events. I can plot it on a black screen or grey background, whatever. There's a raft of issues under there for varying the plot. But this plot, it's a recent observation, and we've got light curves. Here are the light curves reported for this event. This is a light curve, a very definite event. Don't worry about the red dots on that one. Very clear event there, but obviously cloud involved, full drop. This one, a full drop there. That dotted line there got drawn because it's light level is exactly 0. But then look at this one here. There's an event there which has been identified as a skipped frame. And here's a very definite occultation event. Now that goes full drop. That's a partial drop. And when you look at this form over here, the expected magnitude drop was 99%, 4.6 magnitude drop. Now, this situation hasn't been picked up on this event, but that's not a full magnitude drop. That's a full magnitude drop. That looks like a full magnitude drop, but that's not, which raises the question, what's going on there? Why is that? That observation, the observer is Rottenborn, and Rottenborn is this observer, which is chord number 2. So that's that chord there. Why has that observer only got a partial drop, whereas the others had full drops? And it's not a U-shaped drop if it had a graze type event. And that's the type of thing we pick up in the review process when we have the light curves. And we've picked up a range of things like that. So I think that's all I need to do with that. So I'll go up in here and continue there. Yeah. So I've done that. Workloads. This is something which is this year in particular, the number of events we've been recorded has gone up hugely. It's about a 50% increase over last year, at least. And no sign of reducing with remote or automated processing. We've got several observers are set up now to do unattended observing, recording multiple events at night while they're asleep. Mark was talking about having that capability with Astrid. The majority of those events turn out to be single record events because what they're doing is picking up events involving small asteroids. So if the asteroid's only 2 or 3 kilometres diameter, we can just do a recording of it. If we get an event, we get an event. If we don't, we don't. I'm asleep at the time. This has got some issues associated with it. Our current reporting systems evolved when the usual situation was many chords for a single event. Most events were sort of organised multi-chord events. The current situation is that's the exception rather than the rule. In fact, the vast number of our observations are single chord events these days. The huge increase in observing of events has to a large extent come about with a relatively small number of observers reporting a large number of events, such as more than about 40 a year. And in my mind, and this is something which I'm just putting on the table for discussions with the relevant people, the regional coordinators in particular. I think we're getting to a situation where we need to consider our reporting regime in the context of these single chord events. Small asteroids, unlikely to have been observed by any other observer, is our system of filling out an Excel spreadsheet and sending it off to a regional coordinator who waits to make sure there's nothing else, no other observers in it, and then puts it through some software to generate the desired end file and does whatever else. Is that an appropriate burden to put on the regional processing? Are they capable of handling it? Would we be better off with the high volume observers involved with small asteroid events, small asteroid diameters? Should we be looking at them actually creating the final report file, which we need to add to the main file, rather than that intermediate file? Of course, those reports would still need quality assurance processing, but given the huge workloads that are mounting, it's a problem in all the regions. I know Norm's group has had lots of problems in this area. Dave Galt in Australia has issues there, and certainly in Europe and Japan, it's a real problem in Japan. It's an issue that as the volumes go up, the reporting mechanism needs to be reviewed. Now, oops, what am I doing here? Okay, I think this is my last slide. As one gets older, one thinks about where what will happen in the future. And I'm certainly well and truly in that age where those things are in my mind. One of the concerns I have with our overall arrangements with our occultation stuff is we have a high level of dependency on a very small number of people with relevant expertise or technical issues. You have Risto with the Cult Watcher Cloud, very critical in our processes. If Risto was run over by a bus tomorrow, who would be able to pick that up? Yes, it's all open source software that he's got there, but that's a concern. You've got, well, the concern of personal concern to me is what I've done with the cult. And should I get run over by a bus this afternoon, where does that leave us? I should note here that backups of their cult source code are regularly put onto the IOTA, not the server where the occult is loaded. So that's readily available. But in the broader picture, there's a raft of issues associated with what we do, where I have a great concern about the knowledge and expertise is too concentrated. In recent times, I've been strongly encouraging for each of the regions, in the terms of the processing environment, to have at least one person in each region who is competent to fully process observations. Process to the level where observations can be added to our main database with full quality assurance processes undertaken. In other words, effectively each region has somebody where if I was to get run over by a bus, they would be able to take over the processing that I do. And I think it would be a huge mistake if the various regions do not ensure they have somebody that is available and is in a position of the knowledge required to actually undertake the processing. Having it too concentrated to one person, such as myself, is not good for the organisation. In that process, and this is an issue, it's been an ongoing issue in all the regions, strong quality assurance is critical. Our occultation observations have got a very high level of credibility amongst the professionals. I can't overemphasize that. The dealings I've had with the people at Horizons, at JPL, with Didymus and so forth, our occultation results are held in very high regard. And all that comes down to us having rigorous quality assurance processes, which I have to confess should be better documented. But rigorous quality assurance is extremely important to our credibility. It is very easy in for amateur groups for people to say, oh, I got this, and how dare you disbelieve me? Of course I saw it. And some people don't like being questioned of. And from time to time, I see discussions on the various groups showing great enthusiasm about observations they've made without necessarily understanding the potential issues that fly around that can explain their observation or non-observation, and to deal with situations where people say they've got a really unusual observation and, geez, I've got a really exciting discovery. and and you've got to somehow put that down. Many years ago, I had a situation where somebody actually came up with to explain their light curve or their observation. The explanation was the asteroid had a hole in the middle. Um, Never mind, it was caused by cloud. To do the quality assurance process and the overall review process, there is significant learning you've got to go through. I saw Norv shaking his head there. um, there is an awful lot to learn in a practical sense. When you see the raft of events you get and potential explanations, hypothetical explanations, and you've got to be across all the possible things, plus being open to new things. Quality assurance can provide challenges. At one extreme, there are those situations where the observer strongly disagrees with the concerns. You can potentially get into long arguments. I think there'll be a number of people listening who will probably identify me as being involved in those things and say, bug you, Dave Herald, you're a pain in the backside. But years ago, there were a couple of people that one guy I remember lived in Baja, California. If you queried his observation, that was how dare you query my observation? It is correct. It is not open to any discussion. And for what we do, for quality assurance, that is an unacceptable approach. Everybody's observation must be subject to being questioned. And the light curve part, availability of light curves is an important part of that. As light curves have come through, I've looked at some of those with their past observations and think, geez, you reported years ago really high precision observation based on this light curve. You've got to be kidding. The other extreme of the quality assurance process is the observers who don't have a high level of confidence in what they're doing. They put in an observation and the reviewer, myself, very much included in that, comes up possibly with an incorrect issue with it. But the observer says, oh, you say that, okay, that's okay then. They don't challenge the reviewer. Somewhere in there's got to be a balance. And reviewers don't always get it right. But it is right and proper and needed to be in a position where any observation can be queried to make sure that we're comfortable that we've got the right result. And all of this flows back to, or has an impact on workload. And in that context, these, where there is the quality assurance issues and we can't afford the time to go into lengthy debates on individual observations unless it's an extremely important or very important observation. So with the recent Didymos events, I don't know how many man days have gone into analysis of Didymos this year, but that hugely important event. On the other hand, if you get, for example, a single frame observation, which looks at could well be noise, we have no desire to waste time on assessing whether or not it is truly an event or not. Ultimately, the question is, how does it get used? And we can incorporate it into a pulp, but we say, yep, it's there, but we're not going to argue about whether it's truly an occultation or not. We'll flag it as a possible occultation and no astrometry from it, and it's there for being assessed in years to come if it's appropriate. And that's the end. So I guess for that point, open to questions.
Yeah, Dave, this is Vince. Good stuff. I think most of us can agree that because of what our data is going to be used for, in some cases, it might save the world. The scrutiny of the process can't be understated. As far as the processing, the backlog issue, I haven't, I work with Norm, being North America. I don't get into any of the details of what his job is on this, but is there a priority system that's already in place? Obviously, Apathos and Didymos and other type of events would be high on the list, but I don't personally don't have any expectations about when my events get processed. But I try to be diligent in what I provide Norm, because he's the one who has to make the final decision. So is there speaking of other regions that may not have as many occultations, is it possible for them to process ours or vice versa? Kind of like a giant centralized queue that the coordinators could pull from, so it's kind of balances the load. Or is that too political?
No. Let me bring this up. Stats. The screen is still shared, I think. So this is can you people see the, I've got a shared screen that's still being shown. Here's the
we're seeing your camera right now.
See,
I see his. I
see the screen.
You see the screen.
Okay.
with
Yeah,
this form that
a
I'm
light
moving
curve?
around.
No, just a light curve.
Oh,
I see the
What am
full
I-
screen.
Oh,
I'm screen sharing, so I'm assuming.
I'm seeing the full screen.
Yeah, okay, so you can see me drag a form around.
Yes.
Okay. This is a form which gives the statistics. This is just for this year to date. North America, one's processed to date on this 436 events. Europe 352. Australasia 337. That's a huge number in comparison. And East Asia, which is Japan. When you look at the US numbers is not significantly greater than Europe, and not hugely greater than Australasia. The spare capacity does not exist.
I see
The
that.
the advantage that Europe has with their soda system, they've got 15 or 20 people involved in their processing. And it's also an online reporting system, which I'm fairly sure, I don't know whether Wolfgang can make any comments about this when he gets to have a chance to speak. But it's in the European context, it's a huge advantage because the language issues, language issues and the way that's managed there. But I have a personal view that ultimately something like SODIS is where things will go for the reporting environment. And I do have a concern about how much time is spent on taking observations as reported to getting them into the final analysis position. You've got issues floating around about how much you want to put on websites to detail who's reported what in the first instance and where they're located, and how much time is spent on doing that. I don't know. And review mechanisms, the process for that. In terms of the overall priorities, special events like Didymus, I mean, they effectively get pulled out of the mainstream because of the priorities of it. Otherwise, the main driver is the astrometry, being able to report astrometry reasonably promptly so that orbits can be updated on a regular basis to improve our data. We had a long break in that for several years because of a raft of issues, both with us and Minor Planet Centre. I was hoping that was finished at the start of this year, but as a result of the project I got involved with, we've had to hold off a little bit just to review some of the couple of aspects of the error modelling that we have in place. But the desirable position I have is to have our astrometry reported to the Minor Planet Centre every month or two, so that we get the latest orbits available on a very regular, frequent basis, so that we get the best available predictions. I think I've lost my mind as to where you're going there. I'm sorry, I'm sort of a bit tired, jet lagged of getting back home late last night. Did I answer that question adequately?
Oh yeah, the numbers speak for themselves.
Yeah.
We let Wolfgang has his hand up. Should we go ahead and let Wolfgang comment?
Okay, so one of the issues, you put a very strong point to light curves. And I agree, without a light curve, the observation is okay. What can you do if you don't have a light curve? But I have a problem with these light curves. What's reported to Vizier and so on, you don't see the length of the light curves very much. So there is I remember an event, there was an occultation itself, was about 80% or 90% of the track which was shown there. But you don't get any idea what is the noise because you only have 10% of the light curve to the left and the right. So it should be in a way to change this issue, that maybe that the occultation should have a maximum of 20% of the window, what you see there, that we have more ideas what the noise in the system is. If you don't
Yes,
have
Wolfgang, and that can be addressed by insisting upon receipt of the entire CSV file, the entire digital file, not presented
but
as a light curve, but presented as a table of, time versus brightness. And then when you've got the entire, insist that they send you the entire recording, and that will help you properly assess the noise.
Yeah, but sometimes it was not possible to see all this. So we have to discuss this, and yes, this is okay. But if the center, like where the occultation is about 2/3 or even more, about 80% of the light curves, then you can't have any ideas what the, like this or even worse. Yeah, then you have no idea what's the noise of the system. You only can trust the values of signal to noise ratio and so on. So this is one thing what very often happens, that I see just a very small part of the occultation light curve outside the real occultation. So you should
Look, Wolfgang, I agree with you. One of the problems I've had, and particularly this year, is just too many things going on.
Yeah.
I was very keen to get the light curves coming as a matter of course. I have these ones here. This light curve gives quite a reasonable indication what's going on. That's okay there. This one, it's a bit short. Sometimes I'll try to find some shorter ones and some other. So, that's hang on, that's plotted the wrong one. Well, there's one of mine, and that's one from Bill Hanna, which is not properly centered. I have two extremes. One extreme is the actual event takes up 80% of the displayed light curve, and the other extreme is where the observer might have a 1 second event, but the light curve is a minute long. So you look at this light curve and you think, oh, where the earth is it? For the ones which have just given the light curve the whole file, I typically edit those down.
So you're commenting on when people do provide you light curves, how much how they show the event in the light curve, how much of the light curve they show, and how difficult and how that affects how you, whether or not you can assess visually the event.
Yep. And one of the things that I need to do, or somebody needs to do, is actually to provide some sort of guidance for people about what is needed in these light curves. So with any light curve.
Go ahead. I'll comment.
With the light curve, and I'm not sure, I've been trying to find one to easily demonstrate, but here's one with a lot of data points here. You can see you can well see the event there, but you can see the type of noise in that light curve. We have a highly dense light curve. I plot Sylvia.
So you're more interested in the noise than what's down in the data?
A bit of both.
Seems like one's counterintuitive to the other. Make it too wide, you see the data, but you don't see the noise as much. Vice versa.
That's right. There's a balance in there. Now, in these small plots, when you get it very compressed in there, whereas that one's quite larger. But in the main light curve viewer, you can change that. You can expand it out. There's the event there. So there's a small plot that gives you a ready assessment. And with this one, if you're reviewing an event, clear event, pretty clear event. This one, that's a challenging event, that one. And this one, it's you need to see it large, see what's going on there. And just to illustrate this has got a number down there of 7612 on this viewer. If I put in, that's a record number, 7612. That's the detailed light curve. And I can expand that up. And that's the event. And as a visual impression, you can see, well, it's a noisy light curve. Be interesting to see what peyote does with that. Looks like a reasonably clear event there. Not very good over there. That light curve says, if the observer reported something, very precise time on that, possibly room for concern. What I can then do with this, and I don't rely on these light curves for highly precise time, but that's date 2019, October 20. 220, February 20, 2020.
Dave,
February
can I offer?
20. February 10.
Dave,
Yep. Yes, Steve.
I was just going to suggest, and I think Roger and I talked about this before, I would like to see the Vizier submissions, a simple process just uploading the CSV files as they're generated from PyMovie or Tangra, because that would make the whole process of submissions much easier, quicker. You're going to get better, more light curves uploaded that way. Plus, we don't want to lose any data. I know there's a tendency to focus on the event itself, but we don't want to, for the reasons that Wolfgang mentioned as well, you don't want people to go in and trim the thing just to show the event. You want all the data, all the data they've captured. You want as much data as possible. Maybe the submission includes specification for the event time that allows you to quickly zoom in on the time of the event that they think it is when you're looking at the light curve. But something along those lines, I think, would be beneficial.
I agree. I agree 110%. The process in North America now is working pretty well. Good on you, Norm. Norm generates, I think it's Norm or his team generates the light curves from the CSV files, and they come through with the batch of data observations. They're doing the same in Europe, and it's the same in Australia, actually. There's a small number of observers that are doing their own, and I think I'll be encourage them to do it through their regional coordinators.
But I would encourage you to try to find a way to get the observers to do it, because our review team's already overburdened. And if you can make it easy for an observer should be able to just upload a CSV file. That should be easy. So if you can make it that easy, then the observers will do it, and you won't have the review teams busy doing work that could be done by the observer.
Now, hang on. When you say the CSV file,
they already we've already been submitting CSV files as part of the reports in North America forever, and I think that probably happens in Europe as well. So just submit those.
Submit them to who?
To Vizier or to Vizier through Occult, however you want to do it. Maybe we have to develop a.
No, the CSV file is not what gets sent to Vizier.
It's what should be sent to Vizier, because that's the observer's data. I guess that's what I'm saying. If we do any processing, then we've kind of complicated our data chain, because we're now looking at a process data instead of the original data. I think we should just have them upload the original data.
But that doesn't you'd still have to generate the graph yourself. That's not making the observer.
The Occult downloads the data, and then they can just do his own graphs, and so he's
Well,
would be
is the graph just for pretty picture stuff? Is there, or is
No,
there
Yes.
it's so
data
so the reviewers can look at the plot and see what's going on. They can see what's happening with the plot. They don't just rely on the numbers.
In that score, the light curve file that's sent off, it has not manipulated the light curve measurements in the CSV file, other than to normalize it to a maximum minimum value range. The actual data is not processed, but it's concentrated on the data for the light curve, plus has a whole lot of other data associated with it. Associated with this, and it's tied in with the way the whole thing was set up. At Visio, it requires a particular data format, which was something that I set up with Visio years ago. Just uploading CSV files without all the associated data with it will go nowhere at Visio. You've got to have all the you've got to be able to associate the light curve with the event and the circumstance of the event and the asteroid and the star. The solution is just sending the CSV file. There's it's not going to go anywhere as such. It's got to be made more relevant than just a CSV file. If you want to just have
Sure,
a CSV,
I mean you have to tie an event, but so the user would have to do that, but the observer would have to do that as well. But just saying, if you can make it easy for the observer, then it'd be better to have the observers uploading rather than the.
Well, the interesting thing in that process is if you if you've got the observations report file I prepared, then a report like this, and I won't go through the process. Say I've got a CSV file from this observer. If I right click on that, this will open up the my computer is bloody slow at opening things up. I'm just going to put in a random CSV light curve. Yeah, I've selected that observer. It's opened up this form. You now just need to select the relevant CSV file. And over here, ignore that there. Over here, this is reading the, that's the target. There's the CSV file data. That looks good. I set the binning and align that there. Click OK.
What is the binning part? What is this binning thing?
When you've got a video which has been integrated in IOTA, it's the block integration or the blocking stuff. It's just taking, when you've got 4 exposures which are exactly the same, you bin them into one. And that's the block function that you have in IOTA.
Well, wouldn't as an observer who makes the Visio file, I can just include the entire one rather than trimming it. For me, that's just as easy. Can we agree on that's a good solution?
Say that again, that you can just...
Well, say I usually record 30 seconds, or if it's a longer event, I'll do 1 minute, etc. But usually I trim it down because I thought that's what I was supposed to do. But instead, I can just mark the locations in IOTA and say, create the Visio file from all my data. And then there's the argument about whether or not I can't see the noise or not. Everything's there. it's, you know, it's no longer an issue from the observer's perspective. It's easy. It's an easier thing to do to make the decision from
the easiest place to create the light curve file is in fact when you've got all the observations pulled together, because all the bibliographic data about the observer's location, the star details, come from that form and pre-populate the form for creating the file. You can select here which part of the light curve form you want to report the light curve on. So save the whole lot in the CSV file. And at this process, our experience, and Dave Galt, if he's around there, could confirm it. If you know where the CSV files are, then at this stage of having the data in the observations editor, it takes less than 1 minute to create the light curve file.
Yes, I agree.
But why make that the problem of the person who wants to do some data analysis? If I was to submit the entire light curve as a VisiR file, he would already have that data, or they would already have that data, and they wouldn't have to go back and process anything.
An advantage of doing it this way is that it avoids keying errors when you're entering the data. If you just create just trying to think.
Remember, in IOTA, the VisiR file also picks up the metadata from the Excel spreadsheet.
Right.
So it has everything it needs.
Well, if that's the case, yeah.
If you've got a 0.5 second event and you've got 2 minutes of recording, there's no need to include the whole duration of the event. You just got to strike a balance between the length of the event and the show sufficient representation of the full light noise. That's all we want.
Well, that still puts some responsibility on the observer to make that balance. If you have the data, then you can do whatever you want with it.
That's common sense.
Yeah, well, I kind of agree. I mean, it shouldn't be that hard for anybody looking at a graph to see. Oh, get plenty of data points, but it's the event itself is not is spread out enough to see what's going on. Yeah, I mean, but I don't know.
It shouldn't be that you're right. It shouldn't be that, as Wolfgang has said, it doesn't always work that way.
Yeah.
So it's better to have a policy that they include all the data and we can trim it down later as needed. But
yeah, or send out examples to like this is good, this is not good.
Yeah,
it's
the
the example situation which is in my mind.
Yeah, I mean, it should be. It seems like it should be easier than maybe it really is in reality to for people to understand what how many data points do you need in the graph to make so that the reviewer can just look at say just do see a image file of look at an image file of your graph and see what they need to see to assess whether it's a good event or a questionable event. Because Dave showed us a number of examples, and to me it was I thought it was pretty clear the difference between ones that were too smushed, too many data points, so it's just like a bunch of lines, versus spread out to the point where you can clearly see the event, but you've also can you've got enough extra point, you got enough points on either side that you can see get a visual of how noisy is that signal.
But I think Dave just showed that you can stretch it in the viewer, so having extra data is not going to hurt anything.
Right.
It's better to have more than less.
how long will it be? It's just, well, I would say ask the question of how much time would it take the viewer to and open the file and get the and stretch it stretch out the data so that they can assess it versus someone doing just like a screenshot. I mean, like Windows, you push the Windows key, Shift S, and then you can just draw right around the whatever part of your screen that you want and save it as a image.
Now, in all of this, when you're talking about viewing, this is being loaded at Vizier, where the aim is to have it publicly available for anyone. You need to look at the Vizier functionality for it and see how they plot the light curves and the issue of expanding and so forth. Now, I forget the details about that, but in looking at this, you need to have a look at what happens at Vizier. And peripherally here, this is an occultation by Pallas. That's the light curve that's been submitted on that, and there's an event reported in there. And if you look long enough, you can figure out where it is. I think the reported start is there and the end is there.
Oh,
Do I have high confidence in that event?
Good example of more data is needed.
It's an example of something.
Clouds.
No.
No.
You thumb through these things. I mean, that's a nice light curve. That one is clouds. So definite occultation event there, but you've got a bit of noise there. That's got some bit of transparency changes. That was just, that's an occultation there. It's just fine, are they? That's from Dave Galt. I mean, it's easy to flick through these and get a sense of go to that looks like that's an interesting drop there compared to there.
But then if you look at the overall noise in that light curve, I would tend to say, maybe maybe something there, but it'd be like, good luck proving it.
And that's a very important observation, because without seeing light curves, you get a set of the observer reports some event times, but you don't necessarily have the full picture. For anyone looking at it, you need to have the light curve to get an appreciation of the overall reliability or the issues that are involved.
Yeah, well, I can see with that one, you might want to have the full light curve data and generate your own the reviewer generate their own light curve and be able to look at the whole thing as well as zoom in.
Yeah, well, more data also will help show the trends. If the cloud's coming in, you can see the trend of the
right.
Now here's an event where manifestly lacking enough data. I think the event is from in there, but
that's when it's supposed to have occurred.
With that particular event, that's I created that Vizier light curve from the CSV file, and that's all the observer supplied. So, without having to go back to the observer and get him to reanalyze his recording, that's all that was supplied.
Yeah, I'm relatively new here. George Viscomi has been mentoring me. But one thing, like he told me, what he does basically essentially a screenshot of the graph, and I'm using the Astrid, which I love. And he moves the cursor to the middle of the event in PyMovie. If you do move it, so if you can put your cursor at the middle of the event, it'll show a line and give you the exact time of where that line is, and then you
mouse over.
do your screenshot, and that line is captured in the screenshot with the timing of the time of where that line is, which could be I can see where that could be helpful.
Yeah.
So I have a few questions, comments. I'll just roll them off quickly. So the first one is regarding, you said there's not enough documentation out there. I believe you guys have some documentation that you forward around reviewers on how to spot certain things. It would probably be useful if you guys could just send it out to everybody, and then people can get an idea of what's involved and look for these things also in their own light curves. And that might reduce some of the workload and expectations from people as well. Comment about Dave Galt about that observation you just showed up, which didn't have a lot of data in it. If it's not sufficient, maybe just send it instead of just abandoning the observation. Maybe that one, maybe send it back to the user and say, look, this isn't enough. Can you give us some more data? Right? It trains them. You get better results next time. Because now they've learned rather than it going to a black hole and not being aware of it. The other one was regarding Astrid. You mentioned that single automated events related to Astrid would cause an issue for you. So a couple of comments on that. First of all, we're planning on multiple stations recording automated events, right? Because that's more useful if you have multiple chords. But just on another comment for others that are doing single chords, sometimes these orbits aren't very well refined and are quite narrow path events, and having that single observation might actually be useful to refine where the path is. When the sigmas, it's a 3 kilometer wide asteroid and the sigma's like 100 kilometers or something like that, right? For measuring timing, so for validating other timing systems, so I use it for validating Astrid, for validating GPS flashes. I made a device called Stamp of Approval that actually does do accurate time validation, which you can use to validate the timing of these devices. And then the last 2 items were about the subframe timing slide you put up. So the first one was, you said that many observers have a desire to obtain the greatest time precision possible and want to report event times to a fraction of a frame interval. I've seen reports where the uncertainty is given as small as 1/10 of a frame interval. Now, those uncertainties are given based on statistical calculations that happen in IOTA. So are you suggesting that we should derate those arbitrarily because we just don't think they're good enough? Or are you referring to those derating people should be doing when their time isn't accurate? And really, those are 2 separate problems, and maybe they shouldn't be combined in the spreadsheet, right? Because the uncertainty quite possibly and quite normally can be 10 to 15 times less than the frame interval. And the last comment was, which I guess was referring to a comment I made on the forum about a week or 2 ago. It said, I recently saw the comment suggesting you can take double the exposure, but still maintain time accuracy. Following this logic, you can take a series of 1-second exposures and have a timing precision of 30 milliseconds in video context. I'm not quite sure what you intended by that, but just to explain how it works, IOTA works on interpolation. So for example, if you have a 1/4 of a second, you okay, Dave?
Yep.
Look to be concerned there. So
I forgot the camera was on.
Yeah, I was watching if you were all right. So if you have a 1/4 of a second event and a star was to occult, disappear halfway through that 1/4 second frame. So say you got 1/4 second frames, star disappears halfway through that frame, right? It's disappeared 50% through that frame. Now, if you take that frame and the next frame and you sum them together, you now have a 0.5 second frame, right? Half second frame. However, that star has still disappeared at a 1/4 of the point through that first frame. i.e. you sum them together, you integrate them, it still disappears at the same point, it still has the same accuracy. So you can double up. Now, I'm not saying whether you should or not, that's a different argument. What I'm saying is that you can take
That's
the same,
right.
you can take
Mark,
the
I've
same
acquired
event.
some data about this, and the talk I was going to give yesterday was about this exact issue. And
Right.
you're absolutely right, Mark. And you do not lose accuracy, generally speaking, by doubling the exposure time. There is a limit to that because based, as you can intuitively understand, Mark, on the specific frames and their brightnesses that which you're combining. And so it does reduce the accuracy a little bit, but
Yeah.
not so much as people would think.
Yeah. And that's my case for always going as fast as you can, such that you still have enough signal level you can actually pull out something reasonable, right? But the rationale, because I mean, you could always just take an observation and just double up all the frames, right? And you could, it never changes the results significantly, but you need that sampling rate to detect things like, because I don't want a single frame event. It's not very meaningful for me. I've got to, if I can have 3 frames for that by doubling the frame, tripling the frame rate to 30 frames a second, then I've got something that is more meaningful and more likely to pick up, say, a double star or a double asteroid, right? Because the one thing you can't fix is undersampling. Oversampling, you can always resample, but undersampling you can never fix because then you don't have the resolution. So yeah.
My concern in this area is whether there's been adequate testing of the subframe terminations in a practical environment. I know Bob did some testing using some sort of test rig. The Lie movie uses subframe stuff, and I think that produces the I don't want to get into comparisons. There's a raft of issues where we can develop things on the basis of mathematical theoretical principles, which inevitably have some sort of assumptions built into them. And when we're dealing with high time precision issues, and when you see the range of light curves we get, and I've seen, well, I won't go into that. Some of the subtime stuff I've seen on light curves, which are totally inappropriate for subtime things. I'm concerned about the level of testing of our software tools in the environments which they are getting used by some observers to report these effects. And yes, there's you can talk about things at a theoretical, statistical level, but I have an ongoing concern with a lot of the issues involving time about whether there are hidden assumptions behind what's being done and whether there's actually been adequate, if any, testing of the reliability of the assessment. An ideal situation I would like to have, but it'd be hard to set up, is to have a number of telescopes co-located at the same location, all with different gear setups. So we don't want 6 asteroids, but although possibly a couple of asteroids there too, but a range of cameras, range of telescopes, a full range of stuff, record the same event effectively from the same location, and then analyze the results from each setup and compare them. And they should all, if the tools are working properly, the results will be the same. And
But
if they're
wouldn't you
not,
suggest that you should only change one variable at a time? Generally, when you're comparing systems, you want to change only one variable at a time.
what I'm suggesting here, this is a broad brush thing. Let's start off with an assumption. All these telescope setups, we believe we are getting accurate time out of them all. So that means they should all, on the same event, produce the same results. And
But
if
Dave,
they do, then
it's a really separate issue, though, isn't it? This is like more a timing issue, whereas we're talking about the integration of frames.
well, no, it's the whole. Well, you've got light curves of different qualities coming through the different systems. So some, you have a large aperture telescope, small aperture telescope, the range of variability so that the different aspects of all the systems come into play. And at the end result, you'll get a time with an associated uncertainty. Now, if they are fully consistent, then you have full confidence in all the various things there, that they're okay. But then if you have significant variations, then you've got the question to ask of why.
Yeah, I agree with Dave. I think that would be important. We tend to focus on the error sources that we know or think we know.
Yep.
And the final timing we get from an event is the entire process from, and I know with Astrid, a lot of that stuff has been automated, so you basically can't get it wrong, like your position and your elevation and that kind of stuff. But all of that information goes into the processing. The processing is done manually or semi-manually or in an automated way by individuals who then put the information into the sheets, and it goes into the reporting process and goes through and eventually emerges by processes most of us don't understand because it's only the reviewers and Dave that do it, ends up at the Minor Planet Centre. There's a lot of data handling that's going on. It's very easy to assume that, it's very easy to assume that there's only, a few possible sources of error because that's just all you've imagined. If you put 100 scopes together, different things, as Dave suggested, we'd probably get a few surprises. We'd think, how the hell could this possibly have happened? I thought this was working properly. There'll be a bunch of observers that will, realize that they haven't been using the tools properly.
Yeah. Well,
it's just a different type of error.
Yeah, it's a different.
A setup that would be kind of nice would be to have an artificial star where you control the timing, you control the amount of random noise. Of course, that's gets a lot more sophisticated.
I will disagree with that control.
Those things are easy to do. It's easy to have an artificial star. You just use a PPS flash of one of our timers.
Yeah, that's right. It's the most.
Yeah, but you want to be able to inject noise into the light, so that's not constant.
Yeah, this is all different. This is all a different question, though. I mean, timing is one issue, and frame rate is another issue, right? They're independent. They're not the same thing.
Right.
You can have an inaccurate hardware, differences in way people are recording stuff. That's a separate issue. That's worthy of a complete discussion on its own, but it isn't what's being discussed here, which is the integration of frames, and that is invariant, whatever method you're using. It doesn't change the result. And wishful thinking, saying, well, it might not match what the math is. Well, the math is pretty obvious, and if you test it, actually do the test. And the easiest way to do that, to make sure you have the same results, is just purely in the same conditions. Because even if you just spread scopes at the same location, you will get differences, right? The easiest way to verify it is just take existing data and integrate the frames. Just sum the frames together, and you can demonstrate that 100%. And the timing is a separate issue. I mean, that's why I created Astrid, was because of all the timing issues that I saw going on. And yeah, that's a complete minefield. I 100% agree with you. And something needs to be done about that. And and the only way, unfortunately, to do that is to constrain the way that people record events so that it becomes more consistent and the data becomes more meaningful, right? Because at the moment it's just a free for all. Everybody does what they want, and that creates issues.
Yeah, I mean, I don't know. I never took statistics. I mean, I have some broad notion of it, but I know when I look at the way the light curve and see that see that peyote is like saying that, oh, okay, this is where the transition, I think the transition was, and with the error bars, but looking at the amount of noise, the point to point noise. If you just look, let's looking at okay, what's the average of the signal, and then how big are the excursions, and then I look at just imagine that that much excursion happening where the transition is, and it's like it just doesn't seem reasonable to to get even half of that you could really say that the accuracy is even half a frame, with the amount of noise that that it seems to be on on that signal. I say I would I would myself question anything that's less than half of a frame rate with that level of noise. But again, I don't I
Well,
don't
the
know.
purpose of statistics is specifically to address that problem. That's what statistics do.
Yeah,
and
so no,
the
and I
statistics are good, and so we should rely on the statistical analyses.
Yeah, and I realize that, and I assume that
not
that's exactly what
unicorns.
Coyote is doing, is using is looking at the signal to noise and taking that and using that in its calculations.
And this all can be verified pretty easily. I mean, just combine frames, for instance, use LEDs to calculate your timing for testing purposes, right? I mean, if you want to check a system is working, then rig it up, use an LED on it, right? Provided you are emitting the pulses correctly on the LED, which you can verify, then and it becomes beautiful. I mean, the precision and accuracy in that, like with the stamp of approval I designed, getting down to with like 10 frames per second, getting down to 100 microseconds accuracy, right? I mean, it's literally that good because the math and statistics, that's been done in IOTA is that accurate, right? Provided you have the LED issuing the cycle and stuff like that. So it can be verified and it can be checked, and you certainly shouldn't rely on shoving it on a telescope to verify the timing accuracy of anything, because with scintillation, all the telescope issues, poor signal off the star, all those make the situation significantly worse. And comparing device to device, you can't really that way, by using observations is far less accurate than doing it with in a controlled environment with an LED.
Yeah.
Well, I want to thank Dave Harold for bringing up some very important issues. And you can tell that his discussion has stimulated us quite a bit as we discuss it so energetically after his talk. So thank you very much, Dave. And I think we had a pretty good meeting, and I want to thank everyone for participating. And it was good to see your faces and hear from you and hear your opinions. It's a good way to get together to talk about what we do. And I hope to see you all again next year. And we don't know what month it'll be in, but sometime next year, let's get together again and we'll talk about all our issues again. So I think we need to call a close to the meeting now. And I want, again, thank you for coming. Is there anything anyone is urging to say before we say goodbye to one another?
Thank you.
Yep. Thank you. Definitely thank Dave as a new beginner. It's like, processing information and the asteroid size information. What asteroid size are ones to focus on is definitely useful information for me.
Yeah.
Okay. Well, goodbye to everyone, and
Thanks,
stay safe, and we'll be in touch.
Awesome.
Alrighty.
Bye.
Okay. All right.
See ya.
Are you going to do another
Well-
photo, a screenshot?
Oh. we
It's
did
a
that.
little bit too late. Most of the people are
We've
gone.
lost half of our people.
Oh, well.
Put your cameras on. Whoever's left.
Cameras on. Somebody who can do whole screen, take a picture. I can't, as far as I know.
Just did. I did it.
I'll get a screenshot of everybody who's here and has their camera on. There we go. Okay, got it.
Awesome.
Clear
Thanks.
skies, everybody.
You too.
You too. Take
Okay.
care.
Hooroo.
Take
Alright.
care.
Bye.
Bye bye.